Welcome everyone, and thank you for joining us today. Moving over to the topic of today's webinar, best practices for building your own data and digital platform for Industry 4.0. And this is the roster of speakers that is joining you today. So we have Erik Rasmussen, a partner at PwC, as well as Hugo Mattioli, another partner at PwC, and then myself, Petteri Vainikka with Cognite today, with the pleasure of being with you all online today. So before getting into the content today, a little bit of housekeeping issues. So today's webinar will consist of about 45 minutes, split into two short presentations, followed by a larger customer case study, including a live demo. And then we're going to finish off with a vibrant Q&A with all of you audiences on the line today. So again, thank you, Erik and Hugo, for joining us. We do appreciate you being here as experts and sharing the customer case with us today. And for the rest of you and for those who were not able to join today, this webinar is being recorded, and the recording will be made available on demand later on cognite.com, and it will also be mailed out to everyone who registered for today's webinar automatically. A little bit more housekeeping wise, so for any questions that you may come by throughout today's webinar, please do not hesitate to type those into the questions box in the webinar tool, and we will address those in a sequential linear order at the end, all in one. And last but not least, we do appreciate you joining us today. So thank you again for taking the time. We understand it's a busy time for everyone with the fall season having kicked off after the summer break. So today's agenda is looking into what is really a data and digital platform for Industry 4.0, and how does this differ from, for example, an enterprise AI platform of sort or an MES system of sort. Then we're going to touch upon the top 3 mistakes that companies commit when building their own data and digital platforms. And then we're going to zoom into what can you do instead, specifically with the advent and support of low code, and how can you use low code to really realize the combination of smart, fast, integrated, and scalable. And again, a teaser or spoiler here, don't build from scratch. And then to conclude, enough talking, seeing is believing, moving into the live demo part of today's session. And the demo will consist of an energy planning application that really takes advantage of this open, modular, and extendable data and digital platform architecture. And of course, we're going to share that with you on the line today as well. But to kick off on the content side, again, the promise and the reality, there's a double-digit potential of cost savings and performance increase and production efficiency across maintenance, process, production optimization, digital worker enablement, as well as, of course, everything underpinning an improved and more sustainable industrial future for us. However, the reality remains a distant cry from the promise. So lots of ambition and necessity to digitalize and digitally improve operations. Loads of proof of concepts everywhere, many proof of concept factories spinning up here and there. A lot of industrials do look at their proof of concepts as being successful, and they are on paper in an Excel study format at least. However, very, very few of these proof of concepts tend to make it into production. And unfortunately, we see even few of these proof of concepts that have made it to production being ultimately scaled out across a fleet-wide deployment. So as a conclusion of the disconnect of reality and the value promise, we see a lot of companies concluding that we need a platform approach. And there's nothing wrong with the conclusion. It's a very, very rightful conclusion to make. So that brings us to what are the alternatives? And broadly speaking, we have a handful. There is the option of going for an enterprise AI platform, a full stack vendor, someone with a closed offering comprising of the end-to-end solution remit. Again, structurally a little bit limited to select solutions from, limits the ability to pick and choose the best of breed solutions and components for your ecosystem. And of course, perhaps the most critical element, relatively, if not very, very high lock-in and quite a rigid environment to work in. Second option is, of course, to go with the public cloud native approach. So build it yourself on a preferred strategic cloud platform of your choice. Again, this will entail the building up of a sizable development team that is typically the combination of internal development resources and externals. And we see a lot of this in industry. We also see a little bit of a passing of the trend here. So these very pure play do-it-yourself initiatives are oftentimes very, very common in early days. And then as commercially available solutions and more mature commercial components become more readily available, they tend to see a decline in enthusiasm. And the industrial data digital platform seems to be no exception to the rule here. And again, there is a considerable cloud lock-in to be considered in this option, as well as a very, very meaningful cost to develop, as well as a cost to maintain. Then a third one, in particular, for those of you coming from manufacturing companies, we've quite oftentimes heard my MES can do this, so why don't I just extend my MES system? So extending what is there already. And this really is a longer story, but please do reach out if you want to deep dive on this particular topic. But today, we're not going to deep dive onto this, but I will casually flow over them, so you know what you can reach out to us for a deep dive for later on. But really, to conclude, MES systems were not necessarily built to be data and digital platforms for what we need going forward in industry as we move into Industry 4.0. They have a role to play, but again, tools that were built for a particular need tend to be very good at that. The extendability is a different question. And then we're left with the 4 box here. So what then? And that is what we're going to discuss with you and share today. Now, very quickly on the 3, I did promise a very superficial introduction. So there's a lot of overlap between what a data and digital platform does capability-wise and what an MES does. There's also very, very distinct capability sets. And similarly for use cases, again, there is a good buffer of overlap, but there's also quite a lot of difference in applicability areas between an MES and a proper data and digital platform. So again, for this, do reach out to us for more details. So what are the top 3 mistakes, and what is the contrarian proposal that we're putting forward to you in the audience today? Now, rushing into, I mean, the conclusion is a rightful one. You probably need a data and digital platform to make sure that your enterprise can get to where you need to go in an efficient and well-governed fashion. But there's 3 common mistakes we see companies doing when they embark on a do-it-yourself initiative. And again, the Gartner quotes at the start of today's session were really good summaries of what to expect, meaning that this is not a standard development project, and it's probably going to be a lot more difficult than what we expect. And one original sin we see is, large enterprise with lots of resourcing really planning for perfect. Now, predicting the future is hard. It's very, very hard. So if you do plan and put a lot of investment and effort into the planning, it's unlikely the world is going to play out as you imagined. And planning for perfect is oftentimes the enemy of getting something really solid and good done. So agility and resilience, so meaning being able to retain that flexibility in what you're actually building, is actually more important than the perfect theory. So keep that in mind. Perhaps sometimes here like perfect is the enemy of good. Second is this falling into the master data management hell. And again, the theory here is that those who have built their platforms or who are building them quite soon realize that storing the data is not really the biggest challenge. It's ensuring trustworthy, high quality data that is the challenge. And data quality to provide this centrally in a good old MDM remains as distant as it has ever been today from being actually a solution that is viable and can be deployed in a meaningful time frame. If not even more so. So we have an explosion of different data, not just conventional enterprise data, but OT data, engineering technology data, and also visual data. And it turns out that a lot of the use cases have very specific and subjective data quality requirements. And you do yourself a favor by embracing this subjectivity of data quality considerations across the use cases. Third is this enforcing a top-down one stack. So this is what our enterprise uses. This is the only way you're going to do things, and these are the kind of modules in the stack that you can use. Now, that is very, very good academically. It's very, very clean architecturally. It doesn't play all that well with the notion of of a real world environment with lots of moving parts, different teams, different people, different geographies, and different needs. And it turns out that larger enterprises, even mid-market ones, can easily sustain multiple different parallel platforms, assuming that they all justify their own return on investment. So the contrarian proposal is to catalyze the inevitable. So picking a few cues from the mega trend in talent leadership today, which is diversity and empowerment. So apply them to your data management and data platform architecting as well, and actually encourage a manageable, keyword here is manageable, so not, everyone run wild, but encourage a manageable set of parallel platform stacks, promoting openness and data sharing across them. And we'll show you what that looks like in a second. So, what does this open, scalable, and composable data and digital platform that is built in and for the 2020s and beyond, of course, as well, what does it look like? And for those of you who are with us at the very early innings, here's a couple of Gartner kind of cautions. Software engineering leaders cannot buy a digital platform or build one without help. And this is not another software development project with an exclamation mark. Well, luckily, this is not 2010 either. So you don't need to build it from scratch. You don't need to build it from the lowest common denominator building blocks either, but you can build from relatively, if not very sophisticated building blocks. And broadly speaking, you're gonna need three. You're gonna need something to manage your industrial data. That is where the company I represent comes into play, Cognite. We specialize on data contextualization and being the industrial data operations layer. Then you're going to need one or more machine learning or physics process simulation engines. In this case today, we're going to feature Accio as a machine learning engine. And then you will need one or more low-code application development frameworks, where today we're going to feature Microsoft Power Platform. And again, for the Cognite, you can equally well have multiple data stores and data platforms. So you could, splice in a little bit of Snowflake, have some Azure data storage and Google Cloud Storage as well. It doesn't need to be one place where all the data is stored and governed either. And these three combined is ultimately what you most refer to as a data and digital platform. In other words, a digital twin platform. And again, the purpose of that is to allow us to rapidly build, deploy, and scale out digital twin solutions, or just simply put, digital applications. So from my side, I will hand over now, but to conclude, focus and have everyone in your stack focus on what they do best. At Cognite, we do industrial data operations. And then with this, I will hand over to the introduction of the rest of the stack, and then moving on to the use case example.
Good afternoon, everyone. Thank you, Petri. So I'll cover a bit more on the methodology aspect and how we approach building these types of platforms, and the way that we at PwC see this. So as you all know, of course, this is a commonplace, talking about we live in an ever more connected and fast-paced business landscape. The pandemic just came to accelerate some of the things that we were expecting for next decade or so, and so it's paramount that whenever we look at such a digital platform, data and digital platform, we understand all the stakeholders. So ever more connected also means we have much more stakeholders today than maybe a few decades ago. So it's important to maintain this alignment between all the stakeholders. And we at PwC, we have an approach, it's called BXT. And basically it means that because we are a community of problem solvers, we tend, or we want to look at the issues and the problems that we are solving from different perspectives. And from that, we understand that we need to look at always from a business perspective. So viability, where is the value? What value are we trying to achieve? Of course, we cannot forget about the experience. So we need that users and all the stakeholders want to use technology. It brings value to them. So the experience aspect is extremely important. And of course, technology in our world today, technology supports a lot of what we do. So we need to make it tangible. We need to make it real. So from the combination of these three different mindsets or angles, we get a very strong value proposition, and we deeply understand what we are looking into and what we are trying to get out of it. Like I was saying, to unlock value, first we need to understand what value are we unlocking. And this is usually, and like Petri was saying, planning for perfect is not usually the best approach when you're trying to get to value, and you try to get it fast, because if you're not going there fast, probably a competitor will beat you to it. And so we use this double diamond. It's one of the approaches that we use on our BXT approach. And so basically, what we try to understand is, first of all, we try to understand what is the context. Then we try to define some hypotheses, and of course, then we try to experiment, gather feedback, and then adjust. So this is that virtuous circle, so that we can find the value faster, what we are aiming for, and then of course that we can actually deliver it, because all of this is really cool, but if we don't get to the value, if it doesn't become tangible and usable, it serves no purpose. And so that's our approach of our pursuit of better outcomes. This is our mindset, this is our focus, always looking into the goals and what we're trying to get from it. And so a lot of these opportunities, we take a low code approach. And why do we use low codes a lot of these times? Because it allows to remove some surface level complexity on building these technological solutions, and rather lets us focus on the things that we actually should be focusing on. So it's building smart solutions, so solutions that actually bring value. It's of course doing that fast. Time to market is important as it has been, and it's not going away. Of course, this notion of integration, it's extremely important. We are almost every time, we are never working in a monolithic infrastructure. So this notion of us connecting solutions, connecting to a lot of other solutions, either past work or other systems in the company or in the industry. This is a extremely fast way to get to value if you use something that already exists that has that value. So you can poke into that and you can extract some value from that and make it part of your value proposition. And also, of course, and then this is always something when we are building future-proof solutions, scalability is a must. So as you've seen in the approach that I've shown before, we start by trying. We start with smaller visions, smaller pieces of a big vision, but we want them to grow. But that growth needs to be feasible. So things like DevOps capabilities and maintenance capabilities in the future, this needs to be foreseen and planned for while we build it. And so low code allows us to focus rather on this, let's call it the non-functional requirements, rather than on those technical bits and bits that actually on themselves don't bring much value. And so this is the reason why a lot of times we use low code. It allows us to focus on value. The promise of low code, and there's some interesting options, is that you don't code an application line by line with lines of code, but rather you either drag and drop it or you draw it like a flow chart. So it's similar, or it's more close to the way that we think and the way that we design ideas and the way that we expose and communicate. So this allows knowledge to be transferred more easily. It allows for more reusability, that scalability that we were discussing. So in the end of the day, it allows us to do the same thing with as a traditional approach, but it allows us to do it much faster with the same level of quality, with the same sophistication, but faster. And this, of course, in today's business landscape, it's a very it's value in itself. So us being able to be faster, it's a part of the value in itself. That's why we want to go fast, but we still want to maintain very high levels of quality, very high level of attainability to that value. So we need to be in good company, right? And so we need to work with the people that when we integrate with things and when we use data, we need to use good data. When we are using low code, we want to use good low code. So all of these things, when they come together, that's the power, that's the value proposition. So at PwC, we've joined with Cognite and Microsoft with the goal of creating this low code factory. So a curated collection of highly relevant technology assets and solutions that are ready to be used. So as Petri was saying, don't build it from scratch. If there's something else out there that already drives some of the value, just use it and build on top of that. So that's the combined value of such an alliance is what excites us, and then the good things that we can do for our customers and for the community and as an overall. And so this is it. I'll give the ball to Eric.
Thank you, Hugo. Interesting. So what we will try to do and just give you some insight to demonstrate the flexibility and the speed that both Petri and Hugo talk about. So what we will give some insight in is an application we have started to develop. So we will give you an insight in why we are developing what we call the shifter. We will give you insight in how we have developed the architecture and how we have developed a modular and flexible architecture with components. And then we will give you a demonstration on the shifter and perhaps give you some new insight what we are delivering after the shifter. And what you can see here is just a screen on the shifter. I will come back to that during the demo. So what we are trying to do is to actually support what we can call the green shift or the energy to X shift, and actually have application where you can find or develop, validate, and find the best scenario for your green shift. So the last screen you saw, that was actually a shifter for a wind farm. What you see on this screen illustrated is actually a shifter application for electrification of trucks in a mining industry. So this is a electrification mining simulation. Due to some property rights, we are not allowed to demo this now, but that will be the next application within shifter we're gonna release to the market. Where did we start? So what was the challenge when we start? So I will try to explain a little bit. So there is something we call a duck curve, and that is a huge shift in demand and supply due to a significant infuse of solar energy or renewable energy, and also the demand on use of energy from charging EV, electric vehicles, and so forth. So you can actually see there is a curve, demand curve, that is actually growing faster and faster from 2012 all the way to 2020, as we have now. And you see the gap here is shifting highly. Also, we see when you have a huge influx of, for instance, solar, you have a lower demand, and when you have less solar, you have a higher demand. So there is a misbalance with the influx of renewables and also of demand. And if you take the price on this, so you have flexible price as well. So if you take the price on top of this, you have a real challenge. And one of the key challenges for the energy sector moving forward is how to manage the huge influx of renewables together with demand of electricity from new sources. So this was the challenge where we started. And then we said, how can we actually make the duck curve smaller and actually have it more like a smooth curve? And that's why we came up with some solution in the Energy Experience Center we are running here in Stavanger, together with the battery producers. So what we actually saw here, that there is a huge challenge, but there is some ways to actually smoothen the duck curve, is to have lithium-ion capacitors or batteries in between your grid and also the renewable data sources. And then you can build an energy storage system that actually manage and actually make the duck curve smoother. So this was the overarching setup that we started with. So there is fluctuations and there are technology, for instance, Beyonder, but that could be Tesla, that could be others. So there are hardware technology and there's a lot of data. So where did we go from this? We will show what we actually did. So on one side, you see the data sources. So that is actually the renewable profile time series. That is the production capacity from a wind farm or a solar farm. Then you also had the spot time series, and then you had weather time series. So that was the data sources we had. So what we said, that with the hardware configuration, can we, with a modular, adaptable, scalable software configuration, actually build a shifter on top? So that's when we used Cognite, Microsoft, and Accio to actually have this application developed and actually interlink that with the hardware configuration. And on the other end, what we got out of that is we get power release management schedule. So we get rule-based triggers. So when you have a lot of wind, you can, and you have a less demand, you can charge your battery through the hardware configuration. When you have less wind or less solar and higher demand, you can actually release power. So that's why it's that you can actually smoothen out the duck curve, and you can actually build day-ahead profiles. So what we said, that the solution for us is to build an open, scalable, and modular architecture. So then we used our low-code factory on the Microsoft Power Platform. We worked with the logic and the visualization. Accio is a machine learning engine in the cloud, so we just utilize that with predefined APIs. Cognite has been a partner for us for a long time, so we actually use that for the data contextualization and storage of all historical prod times, spot prices, and real-time prices. And then we had the Beyonder, who has the batteries and the system connected through all of this. So this is a highly modular architecture. And the good thing about this, we have tested this on other use cases. So the architecture stays, the architecture support multiple use cases that I will explain a little bit on later on. So this is the architecture. And then for us, speed is an essence. So when we actually start looking into this, and you remember Hugo talked about the design thinking, where we had discover, define, develop, and deliver. So we actually use our own methodology to actually come up with the application I'm going to demonstrate for you next. So this is where we were. So we worked together with our clients on the strategy, the markets research, and the user research. And then that is where we started. Then for the first week, we actually did develop the use case, the business case. We explored the strategic fit. We actually gathered a lot of data and also market data and tried to actually make the use case and the business case to fit. and we did quantify the business case for our clients. In parallel with that, we actually worked with the UX and UA, and then we actually build and sketched up how should the UE and the user interface look like, and we tested that to some users, and we actually put in some core features. And then also in parallel that week, and that was the most challenging task we had, is actually when we actually gathered all data sources, we checked the quality on the data sources, we uploaded all the data up to the Accio machine learning engine, we tested the machine learning engine, and we ran many iterative tests on that, and then we also ingest all the data into Cognite. And in that data and tech architecture, we ingested and tested 3 years of data for the wind farm I'm going to show you. Then after that week, so we used 1 week on that. The second week, we sent everything over to our low-code factory, where we actually looked at the data structure, they build the core workflow, they build the screen, the look and feel, and they loaded up the data batch from Accio, and they explored all the API integrations. And then we actually further continue to work on the machine learning engine. So we did the manual data, the pipeline, the gathering, and we did all the running of the machine learning and tested that the machine learning model was actually predicting the right outcomes. So this was 2 weeks from we had a strategy where we start looking into the energy shifter and the duck curve until we had an application up and running. So this is actually the shifter. The shifter is not really, shifter is very good to look at, but the real power in this is the modular engine that runs behind it. And we have actually tested the architecture and the engine and the machine learning on multiple use cases. So we are now able to actually run it on multiple use cases. So what we actually see here, where you see, this is actually a wind farm in Norway. And you can see this consists of 7 windmills. So it's actually running. And this is the setup of the wind farm. And then we have actually simulated in energy storage, battery storage into this. But you can actually within this, so this only now have 1 plant, but you can actually simulate in multiple wind farms or actually solar farms, and actually run shifter dashboards on multiple farms. So what you see here is just the automated ingest of historical data and day ahead data. But if you then go back to the dashboard, the thing the dashboard does is that here you have historical performance data on the wind farm. And actually on this, we have what we call shifter revenue or shifting revenue. So this is actually the increase of revenue from the wind farm based on battery shifting technology combined with influx of wind, combined with price. So if we run a simulation here now, we can see this is actually tomorrow. But here you can see the red curve. This is not the duck curve because this is actually in Norway. But if this has been run in, for instance, California, you would have a totally different price ahead, spot price ahead setup. On this line down here, we actually have, this is the weather data, actually wind, but you can have wind and solar, you can have different weather data in here. You can run the optimizer. And what you actually see here is that this is what is sent to the energy optimized system, is that in the beginning, midnight, we are actually charging batteries. And when demand peak takes up, we are actually starting to decrease or use battery as a secondary source of electricity. And then you can see that in this period in the middle, in the morning, it's fully charged, and then you are releasing out, and then the next day it will charge up again and release. So this is actually the shifter, how it's set up today, but we are actually building multiple new views on the shifter based on the architecture we have. So this is what we are doing with the shifter further. So we are actually scaling the application through our partners to gain more users, but we are also scaling the shifter through multiple use cases. So what you saw now is wind and energy storage. Solar and energy storage is just the same, but with a different influx of renewables. What we are doing now that are ready to be released is mining electrification. We are using exactly the same architecture to look into the shifter to build scenarios for electrifying trucks in open mines. And some of the use cases we are running there is just amazing. And there we will also do the CapEx and the OpEx, but of course the emissions that is going to be, or the emissions that's going to be reduced with electrification. Then we look into fleet, and of course the last is power solutions. So this is actually the shifter as it is today, and this is, we are looking now, is the shifting scaling process to multiple use cases, but using the same fundamental architecture that we had explained previous.
Without further ado, thank you, gentlemen, both for your contributions, and then we can move over to the question side. Before we kick off with the questions, just one feature highlight. We do have our annual conference coming up in a couple of weeks' time, Ignite Talks, so a virtual conference still, given the COVID environment that we unfortunately still suffer under. But it is definitely worth signing up and registering for. So topic is very, very thematically accurate. Of course, the green wave, us all needing to transform operations into a more sustainable future, and what role does technology, data science play in that, and of course people, culture, politics, and others. We're going to be joined by more than 50 international speakers across industry leaders, policymakers, and technology champions, of course, alike. And we will be joined by thousands of attendees, and we do look forward to seeing you join us as well. And the date is September 21st through 23rd. So again, in 3 weeks' time from now. So with that promotion spot for Ignite Talks, let us move over to the question. I'll kick off with the first one, and this is on the Shift app. What would you see as the major challenge moving forward? I mean, and let's be honest, there's always a challenge. So what's the catch?
It's a very good question. No, what I think is, firstly, is to actually get users on the platform, users on the Shifter platform, and actually have a very good system to pick up improvement potentials, and actually use the scalable platform to actually deliver both on new features but also on new use cases. So scale with users is critical.
It's interesting to find out here that once the technology side is rather taken care of, and you've already landed a modular architecture that got you to your initial goal very, very rapidly, that the challenge is more on the user acquisition side as opposed to the technology blueprint side. At least one worry and one headache less for us. Second one, playing really well to my follow-up question, or not question but statement. What is the benefit with regard to the modular architecture setup, and again, especially as you move forward from where you are today?
Yeah, I can take that. If that's for me, I think actually the modular architecture, of course, it has speed with it, and I worked as a software development with software development companies since the 90s, and the speed you have now, both with low code and the modular architecture and the predefined tools you have, is mind-blowing. So to build Shifter in 2 weeks in the year 2000 or 98 or 95 would never happen. So speed is very crucial, but I also think that to be able to execute multiple use cases based on the same architecture and actually leverage the IP of the platforms is the most beneficial for us. So just remember how much work Cognite has put into the Cognite Data Fusion platform, and to be able to leverage that into a project, it's mind-blowing.
Then I'll jump into the next one. Everything is today marketed as low code. So what level of developer skills is actually required to use this low code?
I think that is Hugo.
Yeah, I'm happy to take this one. Yeah, very good question. I hear this flavor of this question a lot of times. Different people have different opinions. My opinion is that there's two sides of low code. So one is, if you want to use low code as a substitute for a traditional approach, I would say the type of people that you need, the type of skills is the same. You're doing the exact same thing. You just have a different tool to do it. So if you use the same people, you'll get advantage of that, the sophistication of the tool, so you're much faster. That's one side of it. Of course, the other side, which is extremely important, is can you use the ability and the easiness of low code to attract more people to use those tools to get value? Of course you can. So concepts like citizen developers, can you reach out to the edges? When I say edges, to the IT, non-IT edges of companies, to attract all that business knowledge that was unable to use a traditional approach to build software or to build a tool. But if you give them a tool like a low-code platform where they can more easily put their ideas and put their knowledge in to work for the company, that's a huge advantage. So that's a very interesting, and we have worked that with several of our customers, that of course they understand that on one hand, if you want to continue, and of course you do, you want to continue to have this fail-proof, highly secure platforms built by professionals. Of course, you need the same skills. You can build it with low code, but you need the same type of skills. But of course, you have all these other people that have a lot of knowledge that they couldn't use with technology up until very recently, and now all of a sudden they have here a vehicle that they can use to put that power to use. And I think that's a change, a big change. And so yeah, there's different grades of low code, but I see these two things as very, very interesting.
Could just quick follow up on that. I think low code is a fantastic tool and opportunity for technology professionals and developers and non-technology professional and non-developers, e.g. business people, to actually sit down and work together and actually produce fantastic solutions. So it's also works as a bridge between the business side and the technology side.
Good, then next question. Very new to Cognite and the AI solution, but what are the pros and cons with staying solely inside the Microsoft ecosystem, meaning Power BI, Azure, AI, and so forth? From a Cognite perspective, and again, it's not staying inside the Microsoft ecosystem or choosing to work with Cognite. For example, Cognite is fully Azure native, so you can actually, Cognite is physically available on top of and inside the Microsoft ecosystem itself. But we have focused exclusively on being the world's best company when it comes to managing all of the industrial data types, specifically the operational technology data types, engineering data types, as well as visual data types. And we've put a lot of our engineering heads into making those both extremely cost performant as well as a very, very intuitive for people, and I mean domain experts, the non-technologists, to also sort of experience and work with and through using the Cognite Data Fusion platform. So my answer to this would be that you can and you will still stay within the Microsoft ecosystem when you include Cognite into your holistic architecture, your broader architecture, platform architecture. But what we really bring to the fore is a set of unique contextualization as well as industrial data management and data operations capabilities that you will not readily find in the Microsoft Azure native building blocks that Microsoft themselves provide. And again, everything that Microsoft provides, and they're a great partner of ours, is built for a broad or broadest possible customer base, covering also non-industrial verticals. Whereas at Cognite, we're specifically focusing on industrial data management, not really putting that much effort or thought into what the world looks like when we move more pure play into the conventional IT realm of the data management spectrum. And again, no, that's the Cognite perspective, but I'd certainly like to pass the baton on this one to our colleagues on the PwC side. How do you see the difference between Cognite when it comes to industrial data management and, for example, Azure data stores directly?
Yeah, so I don't know. I'll take at least the first stab at this one. So like we said in our slides, we are focusing on getting value. Of course, we have some tools are better for some contexts. We as I'm going to say, a kind of agnostic, we need to look at the bigger picture. And so if that bigger picture is feasible with Microsoft and with Cognite, perfect. We know how to use it. And so the fact that these are modular approaches, it means that you can take one module out and you can put another one in. That makes more sense for your context. So I would say, and then take the example of Shifter. You've seen a lot of platforms that are being used here. If you want to replace that Accio with another AI engine, you could. So, and I think that's the beauty of such a solution, and also one of the biggest strengths is that, and the reason why it can be used in different use cases is that if you need to change a module for something more adequate for that particular scenario, you can, and that won't break the entire architecture. So I don't know if Eric wants to add something, but this for me is...
I think that was a good answer. I agree with you, Hugo.
And again, it's very agreeable from our side as well, and it plays really well into the opening part on really focusing on the modularity, finding the best of fit components into what you need, and also not setting yourself in stone or laying everything in concrete here and now, but retaining that notion of agility and the ability to change as your requirements change. And it's equally perfectly fine that you end up having multiple different modules serving the same function, addressing different use case clusters, for example. Should they be more applicable to those business owners of those use cases, or should they simply be preferred by them because they prefer the user experience of that particular platform interface, for example? So never underestimate the experience side, as our friends already alluded to at the start. So there's always a very, very large human element and experience element. And as we see technology and data management technology moving into the 2020s for real, the battle and the frontier is actually on the user experience, how to make data speak human, how to make data applicable and addressable and available, I mean truly available, not technically, but actually meaningfully available to industrial domain experts themselves in a language that they understand. And so that there's no misunderstanding, industrial domain experts do not understand the language of a data warehouse or a data lake today. So that's all from my side. I see we don't have any more questions, and we actually are on top of our time as well. So sticking to almost to the 45 minutes that we promised, we ran over by a couple of minutes. So with this, I would like to thank everyone for joining us today, and there will be a recording made available later, of course. Thank you to our fabulous guests, Erik and Hugo. Once again, thank you for joining us, and look forward to seeing you gentlemen on something collectively in the future. Thank you again, and have a good day, rest of the evening or afternoon, depending where you happen to be.